Hello everyone, this is Varsha. I'm currently pursuing my BE in Sri Venkateswara College of Engineering, Bangalore. In this session, we will discuss about SVM and its kernel type. Firstly, let us go with what is SVM. SVM is a support vector machine. Let us see the definition of SVM. A support vector machine is a supervised system m- mastering set of rules more often than not to use it for category duties but can also be heard for regression tasks. The key idea. The most important objective of an SVM is to discover ideal hyperplane that pleasant separates special training inside the characteristic area. Application. It is used in textual content categorization, image reputation, and bioinformatics and some extra things. Now, let us see how does SVM works. Hyperplane and matching. Hyperplane. A choice boundary, it will separate different training within the future space. Margin. The distance among the hyperplane and the nearest records factors from either elegance. The data points that lie closest to the hyperplane and affects its position and orientation. The objective to maximize the margin to make certain the great separation between the instructions. Mathematical formula concerning optimization. SVM for classification. SVM is also used for binary classification. A binary classification method employs a linear equation to determine the class assignment. For example, classifying whether a particular mail is junk or not. Now, let us see with the multi-class classification. One versus one and one versus all strategies for dealing with multiple classes. Advantages. Effective in high dimensional spaces, robust to overfitting, in particular in high dimensional area. The disadvantages are computationally in depth with massive datasets, requires careful tuning of parameters. SVM for regression. This is uses same principle as SVM but for regression tasks. Objective of this is to predict continuous values rather than the set of classes. Epsilon insensitive loss. It allows a margin of tolerance, that is epsilon, within which no penalty is given for errors. The application for SVM for regression are time series prediction and the financial forecasting and more. The advantages and disadvantages of SVM for regression is effective for high dimensional data, and it also requires tuning of hyperparameters. Now, let us see what is kernels. Kernel. A kernel is a function that transforms data into higher dimensional space, making it possible to apply linear separation techniques to nonlinear data. The purpose of the kernel in SVM is it enables SVM to handle non-linearly separable data by implicitly mapping the data to higher dimensional feature space. Some of the common kernel functions are linear, polynomial, RBF. RBF means radial basis function and sigmoid function. Types of kernels. Let us see the types of functions. Those are there in kernel. First, let us go with the linear kernel. The formula is k of x of I, comma x of j is equals to x of I dot x of j. The use case for this linear kernel is best suited for linearly separable data. The advantages of linear kernel is simplicity and efficiency. This is also less computationally intensive. Visualization. Graphical representation of a linear hyperplane separating two classes. Now, let us see with the polynomial and RBF kernels. Polynomial kernel formula is k of x of I comma x of j is equals to x of I into j plus c whole power d. The use case of this is it is suitable for data with polynomial relationships. Advantages: can model non-linear relationships. The disadvantage of this model is computationally intensive for larger data sets. Now, let us see with the radial basis function kernel. The formula for this is k of x of I comma x of g is equals to exponent of minus gamma or xi minus xj or square whole. Use case: effective for complex data distributions. The advantage is it is powerful in mapping data to a higher dimension. The disadvantage is this radial basis function requires careful tuning of gamma parameter, that is gamma, hyperparameters, that is gamma. Now, how to choose a right kernel? Factors to consider: nature of data, whether it is linearly or non-linearly separable data. Next, we have to check with the computational cost, efficiency of computation for larger data sets. Next, we should also check with the performance, that is accuracy and generalization ability. Next, cross-validation techniques. We have to use cross-validation techniques to determine the best kernel for the dataset. Example, comparative analysis of different kernels on a sample dataset. Now let us see some of the advantages. Effective in high dimensional spaces. SVMs perform well in high dimensional spaces, making them suitable for problems with many features such as text classification or Gini expression analysis. This is also memory efficient. It uses a subset of training points in the decision function, which makes them memory efficient, especially when dealing with large data sets. Next, robust against overfitting. SVMs maximize the margin between the classes, which helps in reducing the risk of overfitting. Versatile Versatility in kernel selections. SVMs can use different kernel functions to handle various types of data and decision boundaries. Effective for both linear and nonlinear data. By using appropriate kernel functions, SVMs can effectively handle linear and nonlinear data efficiently. Thank you.